Hello everybody. In this video I'm going to go over the routing protocol OSPF. Now, I understand when you go to Canvas and you click here in week 9 that you already have three lectures on routing protocols and OSPF. But the purpose of this lecture is kind of to take over for Dr. Rana. Since you have fall break, this is just going to go over OSPF and how to configure it. Not only that, it's going to tell you why OSPF is important, why it's good to use it, and also I'm going to be going over the different parts of the commands and how to configure OSPF to give you a better understanding of them. So let's go ahead and review the types of routes. Um, as you all have learned, routers build their routing tables with information from three different sources. You've already worked with two of these, the first being connected routes. These are formed through configuring neighboring router interfaces. So the IP-adder and no-shut commands, after you do that on two neighboring interfaces between two routers, a connected route will automatically be created. Then we have static routes. These are created manually by the administrator. We have to create these manually. These are the routes that are not created by connected routes. So this helps routers forward packets that need to go to non-adjacent interfaces and networks. So you already know the command IP route. You do put the destination network, the subnet mask for the destination network, and then either the destination address that leads to the network we want to route to, or the native port on the router we're working on that leads to that destination network. Um, then we have routing protocols. So these are dynamically learned through specific protocols, these types of routes. We have to configure these too as administrators, but as you'll find, I think I would consider them to be a bit simpler. For the purpose of this class, even though there's multiple routing protocols, OSPF is the only one we are really concerned with. So what is a routing protocol anyway? So a nice definition for the textbook states, a routing protocol is a set of messages, rules, and algorithms used by routers for the overall purpose of learning routes. This process includes the exchange and analysis of routing information. Each router chooses the best route to each subnet, and finally places the best routes in its IP routing table. Examples of routing protocols include RIP, EIGRP, OSPF, and BGP. If you need a simpler explanation, basically routing protocols help us create routes without having to make up multiple static routes for other networks. Basically, we configure certain information on our routers, and that part is manual, but the routes themselves actually automatically propagate on the routers. And we'll explain it in a bit, but let's consider this topology I made. To give you a better idea why we would prefer to use OSPF over static routes, say we have this topology here. We have three routers. We have one in the center that connects to these two here on the side, and these side routers each have three subnets they're connected to. So, say you're tasked as an administrator to set up routing to allow PCs from these networks to communicate with each other through routing. So one way we could go about this is static routes. So for R1, we need to create the following static routes. So you need to create a IP route 10.0.0.255.255.255.0, and then S00 for this interface. So basically, we're creating a route for this network here. You've already dealt with this, and I'm sure you all are really good at doing this now. But so basically, you would do that for every network that R1 needs to forward traffic to. So you do R1 for the traffic goes to this, and you do the R3 routes as well. So that's a total of 6 routes. That's a lot of commands. Even though you can press up key and replace a few numbers here and for these interfaces here when you need to, that's still a lot of routes to keep track of, and that's just R1. Um, Static routes, as you see, static routes are time consuming. They're prone to human error and are not scalable. I mean, when you do R2, you have to do all these routes. You have to do all these routes in R3, and on top of that, you have to know how to use default routes. That's a lot of work. And what's worse, when I mean scalability, we're talking about scalability here. It gets even worse when you add another route to, like, say you're adding another subnet to R2, you have to update R1 and R2. And if you were to add another network here on R1, you'd have to update this router in addition to that. And if it were to connect to these as well, if it were to connect, a router were to connect to all three of these networks, for redundancy, you would have to add more static routes to all three of these routers. As you can see, you can imagine how much more difficult this is when you have a large-scale network like a commercial network with hundreds of routers. Static routes are very difficult to keep track of, and really, honestly, they're far more work than what's really necessary. That's why OSPF is much better. So as you see back here with static routes, you have to type 6 different routing commands for R1. With OSPF, you only need 2. You only need the network to write commands for 2 networks. So network 192.168.0.0. This real number here is called a subnet mask, or a wildcard mask. I'm sorry. Instead of using subnet masks, OSPF use wildcard ones. We'll discuss that in a minute. Then you write the word area and then a number. To explain area numbers, it's more important for like multi-area OSPF where you have larger networks, and to reduce OSPF traffic, you divide your network into multiple areas. We're not doing that in this course. You'll do that in CIT 447. It really isn't that hard, but for the purpose of this class, you'll only be using one area number, likely 1 or 0, depending on your lab assignment instructions. So you notice there's a different philosophy when you're doing OSPF. So when you do static routing, you have to write the routes that you want R1 to route to. With OSPF, you're writing the subnets that you want your router to advertise to other routers. So basically, you don't have to write like 10 networks from the other routers. All you need to do is write the routers, or for R1, you only need to write the subnet, or create routes for subnets that are directly connected to R1. So it's advertising these networks to these other routers. And then you go to R2, you basically do the same thing. You write all the routes that are connected to the router, so it can advertise these routes to R1, who can advertise them to R3. So all these routers will have these networks. So with OSPF, routers do not have to write static routes to other routers, nor do they have to write default routes, at least in most configurations. They simply advertise their own routes to other routers. The solution is simpler and much more scalable. I mean, if we were to add another route to R2, we only need to edit R2. That's it. So, how to configure OSPF? Configuring OSPF really just requires a few commands. It's really simple. So the first step is to obviously set up your IP addresses and subnet masks, and then make sure your interface is not shut down. So conft IP adder, type an IP address, and I apologize, this is a subnet mask or subnet ID. This should have been an address. And then you type your mask. Then you type no shut. You've done this throughout the semester. It's still required for OSPF. So once you do that to all the interfaces you need to work on, then you go back to global configuration mode. Type this new command, router OSPF1. Now this number here is the process ID. We'll discuss that in a bit. Then you type this word network, type your subnet ID, type a wildcard mask, the word area, and then area number. You do that for all the subnets that are connected to your router. So for example, as I said before, so R1, so all you have to do is write the commands for these two networks, then 192.168.0.0, 192.168.0.4. That's all you have to write. That's all you have to configure on R1. Then there's this other command. Passive interface S0/1. So the passive interface command I'll discuss in a minute, but that is another thing that's different between OSPF and static routing, and I'll discuss that here. So I copied the example of the commands I have here so we can discuss them. So the first command that you need for OSPF after conft is router OSPF, and then the process ID. This command begins the OSPF configuration. The number at the end is the process ID, so we're using 1 here. The same number should, but doesn't have to be used on all the routers. You can use different process IDs between routers. It's recommended to use the same one just for simplicity. Most likely just going to be 1. Process ID number doesn't really matter. Then you have the network commands. You need as many network commands as you have subnets connected to your router. The router or the network commands define the routes the router will advertise to other routers. Only enter routes for the subnets located on the router you're currently working on. I discussed that before. That's what separates OSPF and most other routing protocols with static routes. Finally, the passive interface command. This command prevents the router from sending OSPF traffic through interfaces that are not connected to another router to reduce unnecessary traffic. Use this command for an interface connected to a switch or a PC. So going back to my topology, you see R2 and R3 are connected to 3 switches each. So when you were configuring OSPF, you need to type passive interface E0/0, passive interface E/0, E0/1, and then passive interface E0/3. Obviously, it's not completely required, but it will be required for your lab assignments, and it's best practice for when you're out in the real world because it improves your network performance doing this. Another major topic you need to understand with OSPF is wildcard masks. Those were the funny looking numbers coming after the subnet IDs in the previous commands. So, why does OSPF use subnet or wildcard masks instead of subnet masks? It's just the way it's designed, but it does help you understand. It is important. I'll explain why. So, wildcard masks are used in place of subnet masks when entering the network commands for OSPF. They control which address portions of incoming traffic are compared and ignored. Zeros represent numbers that need to match, while every non-zero number, the number is ignored. Mostly. When you do, that's true for /16/24/8, the classful subnet masks. But when you're doing the classless ones, it's a little different. It's more on the bit level. There's more zeros on the bit level that determine what bits need to match. But all you really need to understand is this. So, for example, the wildcard mask is 0.0.0.255, and the subnet is 192.168.1.0. So if we were applying the OSPF route to this route would allow an address of 192.168.1.1. So notice how there's 3 zeros in the wildcard mask, and the subnet mask here, these first 3 numbers, it means that any traffic coming through this route, or that is going to be traffic to this route, needs to match 192.168.1. So this address matches because it's in the same subnet. However, this one does not. It's in a different subnet, and this it's compared against this. Since there's 3 zeros here, and these 3 numbers are 192.168.1, but this ends in 2. This address, traffic from this address or going to this address is not going to work. The first 3 octets are compared in this example. 3 zeros, 3 octets are compared. Now, you'll need to learn how to convert subnet masks to wildcards. To do this, you need to first turn all 255s in the subnet mask you're given to zeros. If an octet is neither 0 or 255, subtract it from 255. So, for example, if you were given a /30 address, you have 255.255.255.252, you would subtract 255 from the 252, the interesting octet, and you get 3. So finally, you would turn all your zeros and the remaining zeros in your subnet mask into 255s. By the way, this table, as I wrote here, is from Wikipedia. You just look up wildcard mask or Google wildcard mask Wikipedia. This very, very helpful table will appear. Or I'm going to also post this PowerPoint. You can also use this link. So let's go over a few examples of how to convert wildcard masks. So find the wildcard mask for the 192.168.1.0/24 subnet. So the first step is to write the subnet mask from the CIDR notation, CIDR notation. So obviously 2/24 is 255.255.255.0. So the first step is to convert all 255s to zeros. So you take these first 3 255s, make them all zeros. Now the last step for here is to convert the zeros to 255s. There's 1 0, it needs to be a 255 here, and this is our final wildcard mask. Notice how 255s become zeros and zeros become 255s. And that's an easy step with converting to wildcard masks. So do something a little more challenging now. Find the wildcard mask for the 10.0.0.4/30 subnet. So the first step is to write the subnet mask. We got 255.255.255.252. You can see that from the table. So next we convert the 255s to zeros. So we have 3 255s, we have 3 zeros in the wildcard mask. Finally, subtract the interesting octet from 255. 255 minus 252 is 3. And this is our final wildcard mask. You can see that from the table here. Final one, this is the most challenging one. 172.16.10.0 / 20 subnet. We're going to convert it to a wildcard mask. So start by writing out the wildcard mask. You can see it here. It also appears in this table. So convert 255s to zeros. We've got 2 of those. We're going to turn to zeros in the wildcard mask. We're going to subtract the interesting octet from 255. So 255 minus 240, you can look up in the table right here, is 15. Finally, convert zeros to 255s, and you get the final wildcard mask of 0.0.15.255. So now that we understand this stuff, let's take a look at an example. I'm going to demonstrate how to set up OSPF. It's actually really simple. So to save time, I've already configured all the addresses. Let me scroll these down a little bit so you can see. Okay, do the old switcheroo here. Okay, so here we have a very, very basic network. 2 routers, 2 computers, 3 subnets. So R1 we have on the F00 interface 10.0.0.1. PC I configured to be 10.0.0 or 10.0.100.1 or 10.0.0.100 I believe. Let me double check that. Let's see. Yeah, 10.0.0.100 is the IP address for here. We have the default gateway. I'm sure you all have done that multiple times. For the sake of time, I'm not going to configure the IP address part, but I will be configuring OSPF. So you can also see here that fast Ethernet address has been configured to 10.0.2.1 on R2. We have the serial connection here to be 192.168.0.2. In R1's case, it's 192.168.0.1. We can actually ping those too. 68.0.2. So see, we got a ping. However, if we try to ping PC2 from R1, see what happens. 0.2.100. See, we're having trouble there. Oops. So also, if you try to ping, if you also try to ping PC1 from PC2, you'll see it's unreachable. So obviously routing has not been configured in this network. So instead of static routes, we're going to configure OSPF. So I'm going to stretch this out a little bit. So let's start with R1. So conf t. First command is router OSPF 1. The next step is to do pass. We can do this next. You can do it last if you want, but I prefer to do it second before we're configuring the routes. So passive interface, you can actually just type it as passive int f0/0. This is on R1. So notice the interface I did that to. I didn't do it to the s.0/0 interface because that one needs to be open for allowing OSPF traffic to go between the 2 routers. However, on this end of the router, f0/0, it's just a PC. It's not going to traffic anything. It doesn't know how to. It's not a router. There's no reason for it to receive any OSPF neighbor information or any OSPF routes. So we make it a passive interface. It saves resources on R1 and improves network performance. It's a best practice to follow in the real world. I recommend you start doing it now. So to configure the routes, so we start with the network command. Now we need to type the subnets that are connected to R1. So one of them is 10.0.0.0. Now we're going to do a wildcard mask here. Instead of 255.255.255.0, we're going to do 0.0.0.255. We type an area number, and that's all there is to it for that one network. So we're going to do the other network now. So 192.168.0.0. Wildcard mask is 0.0.0.3. Oops. Area 1. And that's all there is to it, to configuring OSPF. It's just a few commands. You notice how we don't need to put the 10.0.2.0/23 network. It's not connected to R1. R1 can't advertise it, so we don't type it in here. So R2, we're going to do conft router OSPF. Just to demonstrate, let's try this. 2. I recommend using the same ID, process ID, on your labs, but we're going to do different ones here just to make a point. Passive int f says 0, just like the other router. Your network command 10.0.2.0.0. You gotta watch out. I put a /23 here. I gotta do .1.255. Area 1. By the way, I highly recommend you memorize your subnetting. It really helps out with your exams and in the real world. It'll save you a lot of time. 0.0.3 area 1. This is the command for the next network that R2 is connected to. Now watch what happens when I enter this. Just give it a minute. Now you see these messages here, this and this. Those will let you know when OSPF or two routers have OSPF and they've made a connection between each other. They've been able to send routes to each other. So end. So we can leave with this with n copy RUST. So end copy RUST. Okay. Let me show you a little something. Show IP routes. Now you notice here there's this new route here. Oh. Now we always know that the C's represent connected routes. You can even tell that through the IP addresses. But if you look at O here, 10.0.2.0/23. Hey, wait a minute, that's connected to R2. Where'd that come from? OSPF. If you look here in your guide here, O stands for OSPF route. Through the OSPF protocol, we actually got this route. Instead of using a static route, we actually used OSPF, and it gave us this route without even having to type a command to this network. Pretty cool, huh? We can actually see the same thing through router 2. See, we actually have an OSPF route right here to this network. Now, if we try our ping command again, might take a minute. Yeah, so see, don't worry if you've got any periods or after you get things configured, if something's not working, just give it a few minutes. It'll probably do like 1 or 2 dots, and then it'll even out and it'll work. Let's go back to PC1. Let's try to ping PC2. Yeah, see? We can do the exact same thing with PC2. Let's give it a minute here. Okay, ping 10.0.0.100. Yeah. So that's basically how you set up OSPF. It's actually really, really simple. So that's all you really need to know for your lab. If you have any questions, just ask me, email me, or visit me during my office hour. I'm more than happy to help you by appointment if I'm available. I hope you found this video to be easy. All you really, to wrap this up, what you really need to learn is how to do your wildcard masks. You probably will have a quiz or two in Canvas to help you get used to that. You need to know that for your exams, for sure. You need to know how to do that for OSPF as well. You need to understand that OSPF is when you make the routes, you need to use the ones connected to the router. You're not writing routes from other routers on your router you're configuring. And finally, as you saw, the process ID doesn't need to be the same. The area number does. Be very careful. Make sure you use the same area number on every router you're using for this class. Thank you. Thank you for listening. Goodbye.